semiconductor chips. These tiny powerhouses are the backbone of modern electronics, enabling the smartphones, laptops, and even self-driving cars that have revolutionized our lives. In this video, we'll dive deep into the intricate process of chip manufacturing, unravel the inner workings of these remarkable devices, and explore how they are transforming the future of technology. Whether you're a tech enthusiast or simply curious about the technology that powers your daily gadgets, this video will guide you through a comprehensive understanding of the world of semiconductor chips. What are chips? A semiconductor chip, often referred to as a microchip, is a compact set of electronic circuits printed onto a small silicon surface, typically no larger than a fingernail. These circuits consist of millions, sometimes billions, of tiny transistor components that act as switches, controlling the flow of electricity through the chip to perform calculations and processing tasks. Chips serve a wide range of purposes. General-purpose processors, such as CPUs, central processing units, are the brains of computers and smartphones. Specialized chips like GPUs, graphics processing units, handle the heavy lifting for graphics rendering in video games, while ASICs, application-specific integrated circuits, are designed for a single specific task, such as mining cryptocurrency or processing data in a particular device. These chips are part of a revolutionary group of devices known as integrated circuits, or ICs. The first IC was invented in the late 1950s, transforming the electronics industry. Before ICs, electronic devices relied on bulky and inefficient vacuum tubes. The invention of the IC has enabled the miniaturization of electronic devices, allowing us to create compact technology that fits in our pockets. Gordon Moore, the co-founder of Intel, observed that the number of transistors on a microchip doubles approximately every 2 years, while the cost of production is halved. This exponential growth has fueled the rapid advancement of technology in recent decades. Now that we grasp the fundamentals of what chips are, let's explore the intricate manufacturing processes behind these powerful devices, which are among the most sophisticated in the world. How chips are made. Crafting semiconductor chips is an intricate and meticulously precise process. It all begins with the abundant material, silicon, extracted from sand. As a semiconductor, silicon possesses the unique ability to both conduct and insulate electricity, making it an ideal choice for regulating electrical signals within a chip. Silicon is a semiconductor, which means it can act as both a conductor and an insulator of electricity, depending on how it's treated. This makes it perfect for chips, where precise control of electrical signals is essential. Silicon is purified and crystallized into long cylindrical ingots, which are then sliced into thin, round wafers, like the ones used in the chips that power your devices. The journey starts with a pristine silicon wafer, sliced from a single crystal grown in a laboratory over several weeks. This is where the true magic unfolds. First, a layer of light-sensitive photoresist is spread across the wafer. Using a stencil-like mask, ultraviolet light is projected onto the photoresist, hardening it in the desired pattern. Next, the unexposed parts of the photoresist are washed away, revealing the underlying silicon. This exposed silicon is then selectively removed through chemical etching, leaving behind the intricate circuit pathways. To further enhance the electrical properties of the chip, impurities like phosphorus or boron are intentionally introduced in a process known as doping. The electrical properties of specific chip areas are carefully controlled to either allow or block the flow of electricity. Chips consist of numerous intricately patterned layers, often dozens, stacked within a space just a few nanometers thick. After the initial layer is etched, additional layers are added and patterned in a similar manner. Each layer on a chip is carefully designed to perform specific functions, whether that's routing electricity, storing data, or processing information. The patterning process for each layer is repeated multiple times, creating the stacked and interconnected network of circuits that allow the chip to process complex calculations. These layers can be as thin as a few nanometers, hundreds of times thinner than a human hair, yet they contain billions of transistors. Once the layering is complete, the chip undergoes rigorous testing to ensure proper functionality. The chip is then cut from the silicon wafer and encased in a protective package that enables it to communicate with the device it will be installed in. The factories where these advanced chips are produced, known as fabs, fabrication facilities, are among the most complex and costly manufacturing sites in the world. Maintaining the necessary level of cleanliness, even a single speck of dust could ruin an entire batch of chips, rivals that of an operating room. To prevent any contamination, these chips are made in incredibly clean environments, known as fabrication plants or fabs. These facilities are even cleaner than hospital operating rooms. In fact, a single speck of dust, invisible to the naked eye, could cause a chip to malfunction. That's why workers wear full-body suits, and why the air is meticulously filtered to ensure there are no particles floating around. Leading companies in this field include TSMC, Taiwan Semiconductor Manufacturing Company, and Intel. Chips in everyday technology. Semiconductor. Chips are ubiquitous, powering a wide range of devices we use daily. From the smartphone in your hand to the car you drive, these tiny yet powerful components are the backbone of modern technology. Consider your smartphone as an example. Inside, a system-on-chip, SoC, combines multiple essential elements, such as the CPU, GPU, and memory, into a single integrated circuit. The CPU handles tasks like running apps and managing the operating system, while the GPU enables smooth graphics rendering for gaming and video playback. The SoC also includes modems for wireless connectivity and specialized chips for power management and camera processing. The impact of semiconductors extends far beyond consumer electronics. In modern cars, chips control critical safety features like airbags and anti-lock brakes, monitor engine performance, and even assist with autonomous driving capabilities. As vehicles become increasingly sophisticated, the demand for automotive-grade chips continues to grow. Furthermore, in the realm of computing, chips like GPUs have become essential for more than just graphics rendering. They are now critical components for artificial intelligence, AI, and machine learning applications, powering the latest advancements in these rapidly evolving fields. The development of AI models, capable of tasks like image recognition, natural language processing, and autonomous vehicles, is paving the way for even more remarkable advancements in the world of semiconductors. As chips become increasingly integral to our daily lives, the future promises even more captivating possibilities that could revolutionize various industries and transform the way we experience the world around us. The future of chips. As we look ahead, computer chips are poised to become even more powerful and capable. One of the most exciting developments is in the field of quantum computing. Unlike classical computers, which rely on bits that are either 0 or 1, quantum computers utilize qubits that can represent both 0 and 1 simultaneously. This groundbreaking approach allows quantum computers to perform certain calculations exponentially faster than traditional computers. Although we are still in the early stages of quantum chip development, industry leaders like Google and IBM have already demonstrated the remarkable potential of quantum supremacy. Another thrilling area is neuromorphic computing, which mimics the structure of the human brain. Traditional chips process data in a linear, step-by-step manner, but neuromorphic chips process information in parallel, much like the neurons in our brains. This innovative approach could lead to significant advancements in artificial intelligence and machine learning, enabling machines to learn and adapt in ways akin to how humans do. While the future of computer chips looks incredibly promising, the industry also faces significant challenges that we must explore. Challenges in the chip industry. The semiconductor industry, despite its vital importance, faces several significant challenges. One of the most pressing is the global chip shortage, which has disrupted industries worldwide, causing delays in the production of everything from smartphones to cars. The COVID-19 pandemic disrupted global supply chains, leading to reduced chip production, while a surge in demand for electronics as people worked from home created a perfect storm. Geopolitics also plays a crucial role in the chip industry. Taiwan is a critical hub for semiconductor manufacturing, with TSMC producing over half of the world's chips. This has raised concerns about the global reliance on a single region for such a crucial technology. In response, countries like the United States and China are investing heavily in their own semiconductor industries to reduce dependence on foreign manufacturers. Furthermore, the chip industry faces technical hurdles. As chips become smaller and more powerful, we are approaching the physical limits of silicon-based transistors. This has prompted a search for alternative materials, such as graphene or carbon nanotubes, which could enable continued miniaturization and increased power. Conclusion. Semiconductor chips are the unsung heroes powering our modern digital world. From smartphones and laptops to cars and medical devices, these tiny marvels enable the technology we rely on every day. Over time, chips have evolved dramatically, packing more transistors into smaller spaces and driving innovation to deliver faster, smarter, and more efficient technology. Looking ahead, the future of chips is brimming with exciting possibilities. Quantum computing and neuromorphic chips hold the potential to redefine information processing, leading to breakthroughs in artificial intelligence, machine learning, and entirely new forms of computation we've yet to imagine. While challenges like supply chain issues and technical limits exist, the chip industry is poised to shape the future of technology with the right investments and ongoing innovation. These unsung heroes will continue to power our digital world for years to come. Hit the like button and drop us a comment to share your thoughts or ask any questions. And be sure to turn on notifications so you never miss out on our next thrilling video. We'll see you again soon.
If you like my video, share and subscribe.